This is the third part of week 3 on big data part. So now we are going to look at the map reduce. This is data parallel programming model. We will see diagram on that. So since 2008, about 10 years ago, there have been at least 20 terabytes of data has been processed a day. So this is very popular in the major vendor big data platform. So what is map reduce? So this diagram gives us an overview. So you can see there are 4 major components on this. At the beginning, you have input, and finally we have output. From the input to output, we need to go through 4 different stages. I'll explain. The first one is called split. Okay, so basically, in principle, we divide the data into smaller pieces, often into fixed size of pieces. For example, in this case, they divide into 4 split. So the first one contains this part, second one contains this part, the third split contains this part, and finally last split contains one word. But in reality, normally we use a standard HDFS block, which normally contains 64 megabytes as a standard. So that is stage 1, split data into fixed size pieces. The second stage is to do map. Okay. For example, in this example, we are doing text analysis. So we want to actually count how many words Hadoop appears, how many times class appears, how many times good appears, for example. Okay, and then you can see we have 2 E's here. Okay, and then this task we do map, which is for each split. I run a map function. You can see. Then welcome, in this case, have a count 1, 2 has count 1, and Hadoop count 1. So each split we run a count function to calculate keywords, the key, which is a word, for example, class, so how many times this was appeared in my particular split. Okay. Finally is shuffle. So basically what we can do is that a kind of sorting. We sort by the word, okay, individual word. So this one, they also have some sort function. You can see that start with B, C, G, H, I, S. It's kind of sorting. The same word are consolidated, aggregated. You can see, okay, because this appears 3 times. First one from one split, so we got 1 here. Second one from here. Third one here. So I find all these keyword Hadoop, and I have 3 records on that. Okay. Finally, reduce, because we see there redundancy here, right? Because this appears 3 times. So I summarize them to 3. So that value is 3. Okay. Similarly, here is 2. End of day, my output report will each word on the count. So that is the basic concept about map reduce. So this is a particular application in terms of word count, but you can do other process or other data mining techniques, and then end of day we got summarize the result and generate a final report. So we mentioned that Hadoop here because we use Hadoop class to achieve map reduce. So what is Hadoop? So Hadoop is an open source framework, okay? And then they have a key component, which is MapReduce. We have just seen the basic function of that. And also Hadoop Distributed File System, HDFS, which is the one I have just mentioned here, the block, the size of the block, okay? And then is to distribute data. So Hadoop file system, they can store big data over across different machines. They can store such file as a sequence block, and the block file and replicate of file tolerance. So some backup. So that is quite a standard framework. A lot of machines are using. But you need to program your data processing and analysis. So let's look at the fundamental concept, how Hadoop carry out the fundamental task on the MapReduce. For example, the client has sent a job. For example, they need us to do a big data for some task. And then they have a job tracker, which you can imagine is a master whose role is allocate different overall task to subtask to different node to process MapReduce task. So here they have a job allocation to divide it, split work. You can see in this case they have a task tracker which can be considered as a slave. So this is master, this is slave, and then so for each map task, reduce task, they send the result to task tracker and then off to the job tracker to see the process updated for them. So we had a paper published a big data platform, which is for particularly large-scale, national-scale dataset. If you are interested in, you can have a look. So this is source code of the word count platform, or word count in Python. So probably we have not much time to go through that, but most of us have already learned Python basic already. So you can see that there are two things. So so this is open file basic things. Okay, and then for each line, we split a line into words, like what we've seen in previous diagram. So we split them into the word, individual word, and then if we haven't seen this before, we add to the word list. So there's a word list to add a word, and for each word we count. End of the day, we return a file called word count. So we probably need, this is just example, we probably need to spend other time on this text analysis another time. So this MapReduce programming model, you can see that they have a map, so it's a key variable, and then key variable. So they are very preliminary method. So we can see we got two key and the value here. So this is another way to visualize, also in the word count. So basically we need to understand the output is the key. Key is the word, individual word, and the value is the frequency in this case. Okay. So end of the day, this word financial, 1, 2, 3, come out 3. Economy come out 2, etc. So this is quite similar to what we have seen before. So the advantage of MapReduce mechanism is that advantage of MapReduce is that we divided data, we schedule the task, we can handle machine failure in case because we have a backup. We have managed inter-machine communication because, as we have seen before, that for each the task tracker, they need also update the master job tracker information, so they communicate by network. Okay. So this is some experience over the large commercial cluster. So these are machines you can use, process a large size of data, and a list from 2004 at Google. They have 1,000 more than or job per day. So now they have more need to process all the time. Why do we need the Hadoop MapReduce? First, because the large amount of data from different places, and also like Google and Yahoo and Facebook, they also have large different type of graphic, video, and advertise optimization. So they need to have a large volume of data and the process in a runtime. That's why MapReduce is essential. So basically distribute subtask to different machines and aggregate result. So in summary, MapReduce is a parallel programming model. So it's problem of scaling. So you can dealing with a large scale problem and the cost is low. Okay, so high and peak further simpler the programming. MapReduce not suitable all problem, but save a lot of time. So this diagram gives us a comparison between MapReduce and parallel database management system. So they are function and service. So we can see they are quite different, and so they could complement each other in terms of real-world application in different way. MapReduce, the concept is quite simple, and so they are concerned that if MapReduce is too simple, for example, they cannot do join. If we have done SQL, we know the join is quite helpful. So we have different tables. And if we can use join function, inner join, outside join, well-conditioned, etc., we can actually process that in quite efficient way. For example, if we don't need a join, we can filter out a lot of information only when they are related. We can do join and associate the information. If we don't do join, the two tables are independent. So probably you have learned normalization in your database, if you remember. So the structure and the logic of relational database has been established quite a long time. So they have their logic. For example, second form of normalization, third form of normalization. They make the redundancy almost to minimum. Only if we use join, some table can associate through primary key, for example, to associate different information together. But this MapReduce don't have a join function, so that is something concern some people. Okay. So as the last example we have seen, we only need a basic count to different, word count. But in reality, it is likely that we need more sophisticated data mining techniques, which we need to discover some information, not as simple as count. So in order to design a model, we need to apply to new data with some certainty. For example, weather forecasting. If today is 10 degrees, it's unlikely tomorrow will be 25 degrees. So, and then the information will be used. For example, if I know today's degree is 10, so tomorrow is likely like 12 or 9, something like that, which I know, if I need to dress, put more coat on or not. And the information needs to be understandable to human. I know some data mining methods are more, like black box, for example, neural network. But at the end of the day, we still need people to understand the mechanism, understand the result. So actually, they're related to different things. For example, database, machine learning, visualization, statistic. They all have overlapping over a certain area. In the all, they could consider as a data science in a big area. So if, for example, this one, we need a field of some incorrect information. For example, driver's age is older than 150, so that is wrong. And then we probably need some ambiguity. For example, apple could be fruit, or apple could be a company. So these things are something related to data mining. So this diagram we have seen early today, which is about the processing, the whole from the raw data to information and finally to action. Okay. So this is also diagram. So data, process, manipulate data products, and perception and cognition, additional expert knowledge, for example, and then at the end of the day we try to explore the usage. But this is a loop, so some human experts add into information to data mining. So data mining, not only from data, but also from the data scientist, and most of the time you also work with a domain expert who knows what we need to look at for this particular data set to look for information which is useful. So before the end of today's session, this part, I would like to give you some ideas regarding to data mining methods in principle. So there are quite a lot of data mining methods which has been used in textbook. So I give you some basic one. So association. Normally you find a correlation between more items, the hidden pattern data, also correlation analysis. I give you example. So in Amazon, you made the orders, okay, and then you made the orders. So based on what you have bought, Amazon normally give you recommendation and suggest what are the item or product you are likely to buy. For example, you have bought a desktop, so it's likely Amazon will recommend you keyboard or mouse in the recommendation list. Why Amazon has recommended this way? This is because from historical data, most people who have bought a desktop often also bought keyboard and a mouse, for example. So Amazon, based on the historical data, they discovered that the association between desktop computer and keyboard and the mouse. That's why they made a recommendation. They're based on historical data. Classification. That is a very common data mining method. This method is distinguish item between class and group. For example, we can do classification a simple way. For example, we are first year, second year, final year. So that is one way to class people, or use gender. We can classify people as well, female, male students. And also we can use the classify to classify the object. For example, we know some fruit have different color. So lemon is orange, is yellowish color, and the banana is yellowish. And then we can use more than one features to describe the object. For example, if I say this is fruit, this is orange, yellow color, and this is sweet, so I know it's a banana. If it's a fruit, if it's orange, yellow color, if it's sour color, a sour taste, so we need know it's a lemon. So these are the features to describe different groups. Clustering, similar to classification, but they are depend on the similarity of the data item. So there are no class level. So we just roughly group them together. So for example, on the map, you can say this area, that area. So it's more dependent on the distance rather than, so this is this city, that city, if you have houses in different places, you can simply group them by distance to certain places. Okay. Prediction, for example, weather prediction. As we said, example, if today's temperature is 11, so we can compare other information to say for the clouds, rainfall, etc., wind speed, we can make prediction. Okay, sequential pattern or pattern tracking. For example, it's more about event happen in a sequence. For example, video monitoring. And decision tree. Decision tree is a tree structure. I think some of you already have seen that. Each node depends a test on the attributes. A branch denotes the result of a test. Terminal holds a class label. So if we go through that decision tree, we can find different situations where they lead to different results. So outline analysis, for example, I give you an example of outline. So if I have a machine which normally run within temperature 10 to 20, which is it's a range with a normal distribution. In the peak is normally 15 degrees. Okay. However, if I have data collected which shows this sensor had temperature 35, and this only happened once a month. So either this is outlier because this is not within normal distribution range, in a normal range within 10 to 20 degrees, or this could be a fault of detection or sensor thing. So outlier, normally we say the data set 5% extreme data or outlier. Neural network, probably some of you have already learned artificial neural network. the logic of neural network is based on the biological numerical models. So how neuron and send information out. So in somehow it's a black box, and we, unlike decision tree, unlike classification, you have rules, say in this condition what happened, that condition what happened. Neural best tell you the output. Is this true or false? Or this is apple, this is banana, this is orange, etc. But it doesn't tell you why and how this one can be classified, is apple or not. So, however, neural network, if used properly, then can give you very high accurate results. Based on neural network, there are some new technology called deep learning. I think most of you have heard of that, which is more complicated structure in the neural network. So finally, for this big data part today, Jeremy has already listed some textbook and also reading this on Blackboard. So some textbook mining massive data, and also regarding to text processing on MapReduce. So you can have a look of them, or you search relevant information. So thank you very much. So this is the now focus on big data. Thank you very much. This is week 3. Thank you.